What if everything we know about the rise of civilization is backward? What if the Great Pyramids, the megalithic temples, the astronomical calendars carved in stone were not humanity groping toward the light, but reaching back toward a memory already lost? Welcome to Whispered Empires, where we uncover the mysteries hidden beneath the surface of history. Tonight we follow a thread that connects distant cultures who never met, yet built with the same impossible precision, aligned their monuments to the same stars, and carried the same stories of a world destroyed by flood and fire. If this kind of storytelling brings you calm or curiosity, then like this video and subscribe to the channel. Also, tell me in the comments where you are listening from and what time it is. Now, let us begin in the silence before memory, when the earth itself was rewritten by catastrophe. It begins not with triumph, but with darkness. Imagine a sky choked with ash, the sun reduced to a pale disk barely visible through the veil of burning air. Ice sheets crack and shudder under impacts so violent they leave scars in the bedrock itself. Rivers swell beyond recognition, swallowing coastlines, valleys, and everything built upon them. This is not myth. This is geology speaking through layers of sediment, telling the story of a cataclysm that nearly ended the human experiment 12,800 years ago. Geologists call it the Younger Dryas, a sudden and brutal return to Ice Age conditions that interrupted the warming trend following the last glacial maximum. But what caused it? Deep in the ice cores of Greenland, researchers found anomalies, thin black layers rich in elements rare on Earth's crust but common in space. Iridium, platinum, nanodiamonds, and microscopic spheres of melted rock called impact spherules. The evidence points to a fragmenting comet or asteroid striking the northern hemisphere, triggering firestorms, megafloods, and a climate shift so abrupt that entire species vanished within a human lifetime. Mammoths, mastodons, giant sloths, all gone. And what of the humans who witnessed this apocalypse? If they had built cities, carved knowledge into monuments, or gathered in great centers of learning, where is the trace? The answer may lie not in what survived, but in what was remembered. Across the planet, separated by oceans and millennia, cultures tell the same story. In ancient Sumer, the Epic of Gilgamesh describes a great flood sent by the gods, survived only by Utnapishtim, who built a vessel and carried the seed of all life. In India, the Matsya Purana tells of Manu, who tethered his boat to the horn of a divine fish and rode out the deluge. Among the Hopi of North America, Spider Grandmother led survivors into underground chambers until the waters receded. In the Andes, the god Viracocha emerged from the depths of Lake Titicaca after the flood to recreate humanity from clay. The Greeks remembered Deucalion and Pyrrha, sole survivors who repopulate the earth by casting stones over their shoulders. Even Plato, writing in the 4th century BCE, spoke of Atlantis, a great island civilization swallowed by the sea in a single day and night. For centuries, scholars dismissed these stories as primitive fantasy, unrelated coincidences born from the universal human fear of drowning. But what if they are not fantasies at all? What if they are the fragmented memory of a real event, passed down through oral tradition until writing could finally capture the echo? This is where the geological and the mythological converge. The Younger Dryas impact hypothesis, while still debated, finds support in multiple lines of evidence. Researchers have documented widespread burn layers across North America dating to precisely this period, suggesting continental-scale wildfires. They have found concentrations of platinum in sediment cores from sites as distant as Greenland, Europe, and South America, all corresponding to the same narrow time window. The climate data is equally stark. Ice core records show temperatures plummeting by as much as 15 degrees Celsius in less than a decade, a shift so rapid it would have been unmistakable to anyone alive at the time. Sea levels rose by hundreds of feet as ice dams collapsed, flooding river valleys and coastal plains where human populations likely clustered. If even a modest civilization existed before this event, its remnants would now lie beneath oceans, buried under silt, or obliterated by the churning of tectonic and erosive forces over 12 millennia. The survivors, if there were any, would have scattered to higher ground, carrying with them not tools or texts, but the most resilient form of knowledge, memory encoded in story, symbol, and sacred practice. Consider the implications. If a pre-Younger Dryas culture had developed architectural knowledge, astronomical observation, or engineering principles, and if that culture was shattered by cataclysm, then the survivors would become wanderers, refugees carrying fragments of the old world into the new. They would arrive among scattered tribes of hunter-gatherers and share what they remembered. They would teach the measurement of stars, the geometry of stable structures, the management of water and agriculture. To the recipients of this knowledge, these teachers might seem like gods, beings who descended from the sky or rose from the sea, bringing light to a darkened world. The myths agree on the details. Thoth in Egypt, the god of writing and measurement. Quetzalcoatl in Mesoamerica, the feathered serpent who taught farming and astronomy. Viracocha in the Andes, the bearded figure in white who walked across the water. Oannes in Sumer, the fishman who emerged from the Persian Gulf to instruct humanity in the arts of civilization. Are these memories of real survivors, distorted over millennia into divine figures? Or are they simply archetypes, universal symbols the human mind naturally generates? The answer remains hidden, but the pattern is undeniable. And so we arrive at the first question that will haunt this entire journey. Did civilization begin, or did it begin again? Were the great monuments and technologies of the ancient world the product of slow, linear progress from the Stone Age, or were they attempts to restore what had been lost? If the latter, then every ziggurat, every pyramid, every standing stone is not a beginning but a reconstruction. The stones remember, perhaps, what we have forgotten. And if this is true, then the next chapter of our story takes us to the oldest known temple on Earth, a place that should not exist according to the standard timeline, yet stands defiantly in the highlands of Turkey. Göbekli Tepe is its name, and it forces us to ask whether human history as we know it is incomplete. What were its builders remembering, and why did they bury their knowledge beneath the earth? The wind across the Anatolian plateau carries dust older than agriculture, older than pottery, older than the written word. Here, on a barren hillside in southeastern Turkey, archaeologists uncovered something that should not exist. Massive stone pillars arranged in circles, carved with animals and abstract symbols, erected by people who were supposed to be living in caves and hunting with flint-tipped spears. This is Göbekli Tepe, the navel of the world, and it dates to 9,600 BCE, more than 7,000 years before the Great Pyramid of Giza. The site consists of at least 20 stone enclosures, each formed by T-shaped limestone pillars weighing 10 to 20 tons. The pillars stand upright, arranged in concentric rings, their surfaces adorned with intricate reliefs of foxes, vultures, snakes, scorpions, and wild boars. Some pillars bear human-like arms carved along their sides, as if the stones themselves were sentient beings standing in eternal assembly. The level of planning required is staggering. These are not random markers or simple cairns. They are precisely aligned, astronomically oriented, and carved with symbolic intent. Yet there is no evidence of permanent habitation at the site, No homes, no granaries, no signs of daily life. Göbekli Tepe was not a village. It was a destination, a gathering place for something greater. Archaeologist Klaus Schmidt, who led the excavation until his death in 2014, called it a cathedral on a hill. He believed that hunter-gatherer groups from across the region convened here for ritual purposes, perhaps seasonal ceremonies tied to the stars or the harvest of wild grains. But this raises a profound question. How did nomadic bands organize the labor required to quarry, transport, and erect stones of such mass without metal tools, without wheels, without domesticated animals? Experimental archaeology has shown that moving a 10-ton block over rough terrain requires hundreds of people pulling in coordinated rhythm, guided by overseers who understand leverage, friction, and balance. This implies not just cooperation, but hierarchy, planning, and a shared vision compelling enough to mobilize communities over generations. Even more puzzling, Göbekli Tepe was deliberately buried. After centuries of use, the enclosures were carefully filled with soil and rubble, sealed as if the builders wanted to preserve them for a future age. Why would a people invest so much effort into creation only to hide it? Some researchers suggest it was an act of closure, a ritual interment marking the end of an era. Others believe it was a time capsule, a vault of knowledge safeguarded against another catastrophe. The celestial alignments at Göbekli Tepe add another layer to the mystery. Computer simulations of the night sky as it appeared 11,000 years ago show that several of the enclosures align with the constellation Cygnus, the swan, which would have been prominent in the northern sky during the summer solstice. Other structures point toward the rising of Orion, a constellation that later became sacred to the Egyptians and the Maya. The repetition of these stellar markers across cultures separated by thousands of years suggests a shared symbolic language, a common cosmology rooted in the observation of the heavens. Was this knowledge passed down from an earlier source? The carvings themselves offer tantalizing clues. On Pillar 43, often called the vulture stone, researchers have identified a series of symbols that some interpret as a pictorial record of the Younger Dryas impact. A vulture, a scorpion, and a headless man surrounded by circular shapes that could represent the fragmentation of a comet. If this interpretation is correct, then Göbekli Tepe may be the oldest known memorial to the cataclysm, a stone archive warning future generations of the fire that once fell from the sky. But the site also speaks to something subtler, something almost forgotten in our age of written records and digital storage. Göbekli Tepe represents the triumph of memory over forgetting. In the absence of writing, knowledge had to be encoded in durable forms, in stone, in alignment, in repeated patterns that could be taught and retaught without degradation. The precision of the site suggests its builders were not primitive. They understood geometry, symmetry, and astronomical cycles with a sophistication that rivals later civilizations. They knew how to organize labor, how to shape stone, and how to create spaces that resonated with symbolic meaning. This is not the work of people stumbling blindly toward civilization. This is the work of people who already possessed a conceptual framework, an inheritance of ideas that guided their hands. Where did that framework come from? If the builders of Göbekli Tepe were purely indigenous hunter-gatherers, emerging directly from the Paleolithic without outside influence, then we must accept that complex monumental architecture, symbolic art, and astronomical knowledge arose spontaneously in a single region within a few generations. Or we can entertain the possibility that they were taught, that survivors of an older world carried the blueprints with them and planted them here, in the Fertile Crescent, waiting for humanity to rise again. The stones remember. They stand silent, patient, bearing the weight of questions we are only beginning to ask. What was Göbekli Tepe truly for? A temple, an observatory, a school, a sanctuary? Perhaps it was all of these, a place where the sacred and the scientific were not yet divided, where the mapping of stars and the honoring of gods were one seamless act. As we leave this hilltop and journey west toward the Nile, we carry the echo of these stones with us. Egypt, the land of pharaohs and pyramids, claims to be the cradle of civilization, the birthplace of monumental architecture and writing. But what if Egypt too was not inventing, but remembering? What if the Great Pyramid and the Sphinx are not the beginning of mastery, but the restoration of something once known and then lost? The desert holds its secrets tightly, but it cannot hide them forever. The next chapter takes us to Giza, where geometry becomes prophecy and stone becomes immortality. The first light of dawn over the Giza plateau cuts through the desert like a blade, cold, golden, and absolute. The sand glows with the color of ancient fire, and the shadows of the pyramids stretch for miles, sharp as the edge of time itself. Even now, after centuries of study and speculation, these monuments refuse to yield their deepest secrets. The Great Pyramid of Khufu rises with a precision that mocks the limitations of its supposed age. Built, we are told, around 2500 BCE by laborers wielding copper tools and wooden sledges, it contains over 2 million limestone blocks, some weighing 80 tons, fitted so tightly that a blade cannot slip between them. The structure once stood 146 meters tall, sheathed in polished white Tura limestone that reflected sunlight like a beacon visible for miles. Its alignment to true north is nearly perfect, accurate to within 1/15 of a degree. Modern surveyors using laser equipment struggle to match such precision. How did the ancient Egyptians achieve it? The conventional answer involves sighting the circumpolar stars, tracking their rotation around the celestial pole, and bisecting the angle to find true north. But this requires sustained observation over multiple nights, complex calculation, and a level of astronomical knowledge that seems inconsistent with a civilization supposedly just emerging from the Stone Age. Inside the pyramid, the mysteries deepen. The Grand Gallery ascends at an angle of 26 degrees, its corbelled walls forming an acoustic chamber of remarkable resonance. Engineers who have tested the space report that it amplifies sound frequencies at harmonics consistent with the Earth's natural resonance, approximately 7.83 Hz, also known as the Schumann resonance. Some researchers, including acoustic physicist Tom Danley, suggest the pyramid could have functioned as a resonant cavity, converting low-frequency vibrations into standing waves. Egyptologists remain skeptical, attributing the acoustic properties to coincidence. But the geometry feels too deliberate. The ratio of the pyramid's height to its base perimeter equals 2 pi, meaning the structure encodes the relationship between a circle's diameter and its circumference. This implies the builders understood the Earth as a sphere and were modeling its proportions in stone. If we take the pyramid's height and multiply it by 43,200, we get a close approximation of the Earth's polar radius. The number 43,200 is not arbitrary. It appears repeatedly in ancient cosmologies as a key cycle of precession, the slow wobble of the Earth's axis that causes the positions of stars to shift over millennia. To encode such knowledge into architecture 4,500 years ago would require not only advanced mathematics but also centuries of careful celestial observation. Then there is the Sphinx, that enigmatic guardian with the body of a lion and the face of a king. Conventional Egyptology attributes its construction to Pharaoh Khafre around 2500 BCE, carved from a single outcrop of limestone at the edge of the plateau. But the weathering on the Sphinx's body tells a different story. In 1991, geologist Robert Schoch of Boston University examined the vertical erosion patterns on the enclosure walls and the Sphinx itself. He concluded that such fissures could only have been caused by prolonged exposure to heavy rainfall, not the wind-driven sand that has scoured the desert for the past 5,000 years. The Sahara has been arid since approximately 3000 BCE, meaning the Sphinx would need to predate the rise of dynastic Egypt by several millennia, placing its origin closer to 10,000 BCE, when the region was still green and wet. If Schoch's analysis is correct, then the Sphinx is a relic of a much older epoch, a monument from a time before the pharaohs, before hieroglyphs, before recorded history. The face of the Sphinx adds another layer of mystery. It is disproportionately small compared to the body, a detail unique in Egyptian art, which otherwise maintains strict proportions. Some researchers, including John Anthony West, have suggested the head was recarved from a larger lion's head during the reign of Khafre, transforming an ancient monument into a royal portrait. Beneath the Giza plateau, myth and geology intertwine. Ancient texts speak of the Hall of Records, a legendary archive said to contain the wisdom of the gods or the survivors of a pre-flood civilization. While mainstream archaeology has found no direct evidence, ground-penetrating radar surveys conducted in the 1990s by the Stanford Research Institute and the Egyptian Antiquities Organization revealed anomalous voids beneath and around the Sphinx. These cavities are large, symmetrical, and unexplored by official excavation. Whether natural limestone chambers or man-made spaces, they remain sealed, their contents unknown. The Egyptians themselves never claimed to have invented their knowledge. In their oldest texts, they speak of Zep Tepi, the first time, an era when gods walked among men and taught them the arts of civilization. Pharaohs described themselves not as founders but as restorers, rebuilding temples and monuments according to the plans of the ancients. The Westcar papyrus tells of Khufu searching for the secret chambers of Thoth, the god of wisdom, hoping to replicate their design in his own pyramid. If the Egyptians saw themselves as custodians of an older legacy, then the pyramids may not be original creations but reconstructions, attempts to preserve in stone what had been lost in flesh. Egypt's mastery extended far beyond architecture. Medical papyri such as the Ebers Papyrus, dated to 1550 BCE, describe anatomical knowledge, surgical techniques, and pharmaceutical treatments that would not be surpassed in Europe until the Renaissance. Physicians performed cranial trepanation, set fractures with wooden splints, and used honey and mold as natural antibiotics. Prosthetics found in tombs near Luxor have been tested and confirmed as functional, restoring balance and mobility to the wearer. Their understanding of chemistry was equally advanced. Mummification required precise control of natron salts, resins, and oils to preserve tissue for millennia. This was not superstition but applied science, the deliberate manipulation of organic and mineral compounds to achieve a specific result. To the Egyptians, knowledge was sacred because it was inherited, passed down from the gods through the priesthood. Thoth, the ibis-headed deity, was said to have written 36,000 books containing all the wisdom of the world. Though none of these books survive, the legend persists as a memory of vast learning once accessible and then lost. As we leave the Nile and journey north to the mountains of Lebanon, we carry with us the question Egypt poses. Was this civilization an invention or a restoration? And if the latter, from whom did they inherit the blueprint? The next chapter takes us to Baalbek, where stones larger than any at Giza rest in silence, waiting for an answer. In the Bekaa Valley of Lebanon, where mountains rise like the ribs of the earth, there stands a terrace that defies explanation. This is Baalbek, once known to the Greeks and Romans as Heliopolis, the city of the sun. The Roman temple complex here is magnificent, with towering columns and intricate carvings that speak to the grandeur of imperial ambition. But it is not the Roman work that draws the eye of those who seek deeper mysteries. It is the foundation beneath, a platform of stones so massive they seem to mock the very concept of human limitation. 3 blocks, known as the trilithon, each weigh approximately 800 tons. They rest side by side, perfectly cut and aligned, with no mortar, no gaps, no space for doubt. Beneath them lie smaller stones, though smaller is relative, each weighing 300 to 400 tons. To stand beside these megaliths is to feel a physical dissonance, a sense that something fundamental about history is wrong. No crane in the Roman world, not even the ingenious treadwheel hoists used to build the Colosseum, could have lifted such masses. Modern industrial cranes struggle with loads over 1,000 tons and require extensive preparation, reinforced ground, and modular lifting. Yet here they are, seated as if by giants. In the nearby quarry, the mystery compounds. Lying at an angle, partially freed from the bedrock, is a monolith known as Hajar al-Hibla, the stone of the pregnant woman. It weighs an estimated 1,000 tons and appears to have been abandoned mid-transport. For centuries, it was considered the largest hewn stone on Earth. Then, recent excavations uncovered another block still embedded beneath it, the Stone of the South, estimated at 1,200 tons. And deeper still, archaeologists found a third, even larger block, the Forgotten Stone, calculated to weigh over 1,650 tons. These are not natural formations. They are quarried, shaped, and prepared for movement. But by whom and with what technology? Mainstream archaeology attributes the trilithon to the Romans, suggesting they incorporated an earlier Phoenician or Canaanite foundation. However, the weathering patterns on the megaliths are visibly older than the Roman structures built atop them, indicating the lower terrace predates the imperial period. Roman historians make no mention of moving such stones, and no Roman engineering text describes a method capable of handling such weight. The silence in the historical record is deafening. Some researchers have proposed that the stones were moved using a combination of levers, rollers, and massive labor forces numbering in the tens of thousands. Yet even with such resources, the physics remain problematic. Moving a 1,000-ton block requires not only lifting it but also controlling its momentum over uneven ground. A single miscalculation could result in catastrophic collapse, destroying the stone and killing dozens of workers. The precision with which these stones are placed, flush against one another with tolerances measured in millimeters, suggests not brute force but mastery, an understanding of balance, friction, and perhaps other principles we have yet to rediscover. Could they have used sound? This question arises repeatedly in discussions of ancient megaliths. Acoustic levitation, the use of focused sound waves to counteract gravity, is a real phenomenon demonstrated in laboratory conditions with small objects. Extrapolating this to multi-ton stones requires energy sources and amplification methods far beyond current technology, let alone ancient capabilities. Yet myths from cultures worldwide speak of stones moved by chanting, by song, by the voice of gods. Are these mere fantasies or faint memories of a technique we no longer understand? The legends of Baalbek itself tell of giants building the fortress under the command of Nimrod, or of the Nephilim, the hybrid beings mentioned in Genesis who walked the earth before the flood. The layout of Baalbek offers another clue. When viewed from above, the temple complex forms near-perfect alignments with solar and lunar events. The long axis of the platform points toward the rising sun at the summer solstice, while lateral walls capture the shadows of the equinoxes. This is not accidental. The entire site was designed as a cosmic instrument, a place where the movements of heaven could be marked and honored on Earth. Some modern engineers studying Baalbek structure have proposed that the massive stones served not only as foundations but as seismic dampening systems. The region sits on a tectonically active fault line, and the interlocking fit of the megaliths could stabilize the entire platform against earthquakes, dispersing shock waves through the mass of stone rather than allowing them to concentrate and fracture. Others have suggested the stones could act as resonant amplifiers, transmitting or absorbing low-frequency vibrations from the Earth's crust. This may sound speculative, but similar acoustic phenomena have been measured at other ancient sites, including Giza, Stonehenge, and Tiwanaku. If the builders understood that certain configurations of mass and geometry could interact with natural frequencies, then Baalbek becomes more than a temple. It becomes a machine. Why such impossible stones? Perhaps the answer lies not in practicality but in symbolism. To move the immovable, to anchor the heavens to the earth, to build with such permanence that even cataclysm could not erase the memory. The name Baalbek means city of Baal, the Semitic storm god associated with thunder, lightning, and fertility. If Baal was a god of vibration, of energy descending from the sky, then perhaps Baalbek was his conductor, a place where divine force could be channeled, focused, and made manifest in the world. The Romans later reinterpreted Baal as Jupiter, preserving the association with thunder and maintaining the site's sacred function even as they reshaped it to fit their imperial cosmology. As we leave Lebanon and cross the ocean to the Andes, we carry the weight of these questions. If Baalbek stones were laid by an earlier, unknown culture, then that culture possessed engineering knowledge equal to or exceeding anything the Romans, Greeks, or Egyptians achieved. And if that culture vanished, then their legacy survives only in stone, in myths, and in the suspicion that we are not the first to reach for mastery. The next chapter takes us to Sacsayhuaman, Ollantaytambo, and Machu Picchu, where Inca walls fit together like living tissue and legends speak of stones softened by plant extracts. The stones remember what hands shaped them, even if history does not. The Andes rise like frozen waves. Peaks so high the air itself grows thin, and the sky deepens to a shade of blue found nowhere else on Earth. Here, above 3,000 meters, where clouds gather and disperse like breath, the Inca built walls that defy not only gravity but comprehension. At Sacsayhuaman, just outside the city of Cusco, massive stones interlock in zigzag formations, their edges carved into complex polygonal shapes that fit together so precisely that not even a sheet of paper can slide between them. Some blocks weigh over 120 tons, yet they sit perfectly balanced, flush against neighbors of entirely different geometry. There is no mortar, no cement, no adhesive of any kind. Only stone meeting stone in flawless union. The rock here is diorite and andesite, among the hardest stones on Earth, resistant to chiseling even with modern steel tools. Yet every surface curves slightly, as though the stone had been molded while soft, then frozen into its final form. How was this achieved? Conventional archaeology points to hammerstones, bronze chisels, and abrasive sand, combined with immense patience and labor. But experiments replicating these techniques struggle to produce even crude approximations of the precision seen at Sacsayhuaman. Bronze tools dull and fracture against such hard stone. The time required to shape a single block using primitive methods would stretch into months or years, yet the Inca built entire cities within decades. Some researchers note a curious detail. Certain joints at Sacsayhuaman and Ollantaytambo show signs of vitrification, a glassy smoothness that suggests exposure to intense, localized heat. Whether this resulted from friction, fire, or some other process remains unclear. Legends recorded by Spanish chroniclers speak of plant extracts that could soften stone, allowing it to be shaped like clay before hardening again. One such substance, called jacha or punko kunka, was said to be known only to Inca stonemasons, who guarded the secret jealously. Whether this is myth, metaphor, or a lost technique misunderstood by European observers, we cannot say. But the idea persists, woven through Andean oral tradition, that the ancestors knew how to speak to stone, to change its nature through understanding rather than force. Another possibility, equally speculative but rooted in observed phenomena, involves acoustic shaping. Sound waves at certain frequencies can cause materials to vibrate, loosen, and even fracture. If the Inca understood resonance and how to focus it through geometry and rhythm, they might have been able to manipulate stone in ways we have yet to recreate. The absence of evidence is not evidence of absence, especially when the evidence would have been knowledge, techniques passed orally and lost when the Spanish conquest severed the chain of transmission. What we do know is that Inca walls are seismically resilient. Peru sits along the Pacific Ring of Fire, one of the most earthquake-prone regions on the planet. Modern buildings in Cusco crumble during tremors, yet the Inca walls remain standing. The polygonal design disperses seismic energy through irregular joints, preventing the concentration of stress that causes fractures in uniform masonry. Each stone moves slightly during a quake, then settles back into place, a living architecture that breathes with the earth. This is not luck. This is deliberate engineering informed by centuries of observation. The Inca also mastered suspension. Their rope bridges, woven from ichu grass, spanned deep gorges and roaring rivers, some stretching over 30 meters. The most famous, the Quechua Bridge, is still rebuilt every year by local communities using traditional methods. The process involves braiding thin fibers into thick cables, tensioning them across anchor points, and weaving a walking surface that sways but holds. These bridges required precise calculation of load, tension, and decay rates, as grass weakens over time and must be replaced regularly. Yet for centuries, they carried not only foot traffic but also llama caravans laden with goods, connecting the vast road network that spanned the empire. At Ollantaytambo, the mystery intensifies. Here, massive pink granite blocks form the Temple of the Sun, each stone weighing up to 50 tons. The quarry for these blocks lies across the Urubamba River, high on the opposite mountainside. The logistics are staggering. The Inca would have had to lower these massive stones down a steep slope, transport them across a river prone to flooding, then haul them up the terraces of Ollantaytambo to their final position. All without wheels, without draft animals capable of bearing such weight, and without metal tools strong enough to shape granite. The surfaces of these blocks show raised rectangular bosses, geometric protrusions that some researchers interpret as lifting handles or alignment marks. Others suggest they served a more esoteric purpose, perhaps as nodes in a system of measurement or energy flow understood by the builders. The stones were never finished. The temple remains incomplete, abandoned mid-construction when the Spanish arrived, freezing a moment of work in perpetual suspension. Standing among these half-placed megaliths, one can almost hear the silence of interrupted labor, the sudden halt of a civilization in its prime. The Inca themselves claimed no credit for the oldest stonework. They attributed the most ancient and precisely fitted walls to an earlier people, builders who came before, perhaps during the time of Viracocha, the creator god who emerged from Lake Titicaca after a great flood to reshape the world and teach humanity the arts of civilization. Further into the mountains lies Machu Picchu, the lost city of the Incas, perched on a ridge 2,400 meters above sea level. Discovered by Hiram Bingham in 1911, though never truly lost to local people, it remains one of the most breathtaking examples of architectural harmony with landscape. The city is built around natural rock formations, incorporating boulders into walls and terraces as if the stone and the structure were born together. Its alignment follows celestial events with precision. The Intihuatana, a carved granite pillar, casts shadows that mark the solstices with such accuracy that modern astronomers use it to calibrate their instruments. On the winter solstice, sunlight illuminates specific windows and altars in sequence, a choreography of light and stone that transforms the city into a living calendar. The drainage system at Machu Picchu is equally remarkable. Spring water from nearby peaks was channeled through 16 stone fountains, each carved from a single block and angled to maintain constant flow regardless of pressure. These fountains still function today, over 5 centuries after their construction, testament to engineering that understood not just form but function, not just beauty but necessity. The terraces that cascade down the mountainside serve multiple purposes: agricultural production, erosion control, and thermal regulation, creating microclimates that allowed crops to flourish at extreme altitude. Night falls over the Yucatan like a velvet curtain, heavy with the scent of rain and earth. Above, the stars blaze with an intensity unknown to modern cities, each constellation sharp and clear against the void. The Maya knew these stars by name, tracked their movements with obsessive precision, and built their cities as mirrors of the heavens. But they did not stop at visual alignment. They understood something subtler, something almost forgotten in our age of noise and distraction. They understood that architecture could sing. At Chichen Itza, the pyramid of Kukulkan rises from the jungle floor in 9 terrace levels, each step carefully calculated. Twice a year, during the spring and autumn equinoxes, the late afternoon sun casts shadows along the northern staircase that form the body of a serpent, a pattern of light and dark that appears to slither down the pyramid toward the earth. The effect lasts only a few minutes, a fleeting union of geometry, astronomy, and symbolism. But this is not the pyramid's only voice. When a visitor stands at the base and claps their hands, the pyramid responds. The echo returns not as a simple reflection but as a transformed sound, a sharp chirp that mimics the call of the quetzal, the sacred bird whose brilliant green and red feathers adorned Maya rulers and whose cry symbolized divine presence. Acousticians from the University of Texas and the National Autonomous University of Mexico have tested this phenomenon extensively. They concluded that the step height, angle, and porosity of the limestone combine to filter and shape the returning sound waves, amplifying certain frequencies while dampening others. The result is an acoustic signature almost identical to the quetzal's call, a sound no natural echo could produce without deliberate design. This was not accident. This was engineering. The Maya built their pyramids to speak, to transform human gesture into divine voice, collapsing the boundary between the material and the sacred. The same principle appears throughout Maya architecture. At Palenque, the Temple of Inscriptions features interior chambers with acoustic properties that amplify chants and drumbeats, creating reverberations that can be felt as much as heard. At Uxmal, the Pyramid of the Magician, built on an elliptical base rather than the typical square, orients precisely toward the setting sun on the spring equinox. Whispers spoken at one end of its courtyard carry clearly to the opposite side, a design that allowed priests to communicate across distances or to create the illusion of disembodied voices, messages from the gods echoing through stone. The Maya were not only architects of sound but also masters of time. Their calendar system interlocked multiple cycles with mathematical elegance. The Tsokin, a 260-day ritual calendar, meshed with the Hab, a 365-day solar year, creating a larger cycle of 52 years known as the calendar round. Beyond this lay the long count, a linear progression spanning thousands of years, recording dates from a mythical starting point in 3114 BCE. When the long count completed a great cycle on December 21, 2012, modern doomsday prophets imagined apocalypse. But to the Maya, it was simply another turn of the wheel, the end of one Bak-ton and the beginning of another. Their astronomical observations achieved precision that rivals modern instruments. Without telescopes, they calculated the length of the solar year to within 0.0002 days of the true value. They tracked Venus with such accuracy that their tables predicted its cycles over centuries, accounting for the planet's variable speed and retrograde motion. Venus was sacred to them, associated with the god Kukulkan, the feathered serpent who descended from the sky to teach humanity. The planet's movements dictated the timing of wars, coronations, and agricultural rituals. To the Maya, the cosmos was not distant but intimate, a pattern woven through every aspect of life. At El Caracol in Chichen Itza, the observatory tower features narrow windows aligned with specific astronomical events. One window tracks the southernmost setting point of Venus. Another follows the equinoxes. A third marks the rising of certain stars. The building itself is circular, unusual in Maya architecture, which favored rectangular forms. The spiral staircase within, from which the structure takes its name, ascends through darkness toward a chamber open to the sky, a symbolic journey from earth to heaven. The precision of these alignments suggests sustained observation over generations. Data passed from one astronomer priest to the next, refined and recalibrated as understanding deepened. This was not superstition. This was science expressed through stone. The Maya also developed a sophisticated writing system, one of the few fully developed scripts in the pre-Columbian Americas. Their glyphs combined logographic and syllabic elements, allowing them to record history, mythology, astronomy, and mathematics on stelae, codices, and temple walls. Tragically, Spanish conquistadors and missionaries destroyed most of these texts, burning them as works of the devil. Only 4 codices survived, fragile remnants of a vast literary tradition. The decipherment of Maya script in the 20th century revealed a civilization obsessed with recording time, tracking cycles, and preserving memory against the erosion of forgetting. But perhaps their greatest innovation was color. Maya blue, a pigment used on murals and ceramics, baffled chemists for decades. Unlike ordinary dyes, it never faded, resisting even harsh acids and UV light. Researchers eventually discovered that the pigment was created by heating indigo dye with a rare clay called palygorskite at precise temperatures around 200 degrees Celsius. The molecules fused, forming a hybrid organic-inorganic compound so stable it survived centuries of humidity, sunlight, and time. The Maya had achieved a form of nanotechnology, manipulating matter at the molecular level to create permanence. Their cities were not silent structures but instruments designed to resonate with cosmic and earthly forces. To walk through Chichen Itza, Palenque, or Uxmal is to move through spaces calibrated for sound, light, and shadow, spaces that respond to human presence and celestial motion. The architecture was alive, breathing with the rhythms of the universe. If civilization is remembrance, then the Maya were remembering how to build not walls but conversations, dialogues between stone and star, human and divine. As we leave the jungles and cross the world to the Indus Valley, we carry the echo of pyramids that sing and calendars that turn like gears in an infinite clock. The next chapter takes us to cities built on grids older than Rome, where every street ran straight, every house had plumbing, and a script still unread whispers secrets from the clay. The winds of Sindh and Punjab sweep across a landscape of quiet ruins, brick walls half buried beneath centuries of dust. Here, where the great rivers once carved green corridors through the desert, lies one of humanity's most enigmatic civilizations. The Indus Valley culture, also known as the Harappan civilization after its first excavated city, stretched across nearly 1 million square kilometers from the Arabian Sea to the foothills of the Himalayas. It was larger than Egypt and Mesopotamia combined, yet it left behind no grandiose temples, no towering ziggurats, no statues of conquering kings. Its power flowed not through monuments but through systems, through the quiet mastery of order itself. At Mohenjo-Daro, the Mound of the Dead, archaeologists uncovered streets laid out in perfect grids, running north-south and east-west with geometric precision. Every house, whether humble or grand, featured private bathrooms, wells, and waste disposal systems that connected to main sewers running beneath the streets. These sewers were lined with fired brick and covered with removable slabs for maintenance, the earliest known organized sanitation system in human history. The attention to hygiene was not an afterthought but a founding principle, woven into the very design of urban life. The Great Bath at Mohenjo-Daro stands as the centerpiece of this philosophy. A massive public tank measuring 12 by 7 meters, lined with waterproof bitumen and fed by an intricate drainage system, it was not merely functional but ceremonial, a place where water, cleanliness, and spirituality merged. The steps leading down into the bath are worn smooth by millennia of feet, testament to its sustained use over centuries. To the Indus people, purity of body and purity of spirit were inseparable, a principle that would later echo through Hindu, Buddhist, and Jain traditions. Across the civilization, from Harappa in the north to Dhalavira in the south, the same architectural standards repeated. Bricks were manufactured in a uniform ratio of 1 to 2 to 4, ensuring interchangeability and structural integrity. Streets maintained consistent widths. Weights and measures were standardized, cubical stones of chert marked with increments based on a decimal system, evidence of mathematical sophistication and centralized planning. Yet there is no sign of palaces or royal tombs, no monuments celebrating individual rulers. Governance appears to have been collective, distributed through design rather than decree. The power of the Indus Valley was the power of the grid, silent, egalitarian, and enduring. The Indus script remains one of archaeology's great unsolved puzzles. Thousands of seals have been recovered, small square tokens carved from steatite and engraved with animals, human figures, and rows of symbols. These seals likely served as identifiers for trade goods, markers of ownership, or administrative records. The script itself consists of approximately 400 distinct signs, too many for a simple alphabet but too few for a purely logographic system like Chinese. Despite decades of study and computational analysis, no bilingual inscription has been found, no Rosetta Stone to unlock the language. Some linguists suggest the symbols encode an early Dravidian language, ancestral to Tamil and Telugu. Others argue the script is not linguistic at all but a symbolic data system, compressing economic and cosmic information into visual shorthand. One seal in particular has captured imaginations. It depicts a seated figure surrounded by animals, horned and cross-legged in a pose strikingly similar to later depictions of Shiva as Pashupati, Lord of Beasts. Is this continuity or coincidence? Did the religious iconography of Hinduism emerge from Indus roots, or are we projecting later beliefs onto ambiguous images? What is certain is that the Indus civilization was remarkably peaceful. Archaeological evidence reveals almost no weapons beyond simple hunting tools. Fortifications are rare, and mass graves indicating warfare or violent conquest are virtually absent. For over 7 centuries, this culture flourished without the militarism that defined Mesopotamian city-states or Egyptian dynasties. How did they maintain cohesion across such vast distances without armies or centralized authority? Perhaps the answer lies in shared identity rooted in common standards, mutual benefit through trade, and a cosmology that valued balance over domination. The end of the Indus Valley civilization came not through conquest but through environmental collapse. Around 1900 BCE, climate studies suggest the monsoon patterns shifted, reducing rainfall and causing rivers like the Sarasvati to dry or change course. Without their lifelines of water, cities slowly depopulated. People migrated eastward toward the Ganges, carrying fragments of their culture into new regions. The urban grid dissolved, but the knowledge did not vanish. Transformed. In the hymns of the Rigveda, one of the oldest sacred texts known, there are references to 7 sacred rivers, to the Sarasvati as the mother of floods, to cities aligned with cosmic order. The Vedic fire altars followed geometric ratios nearly identical to those used in Indus construction. From these echoes emerged Vastu Shastra, the ancient Indian science of architecture, which still governs the design of temples and homes today. Vastu principles dictate orientation, proportion, and spatial harmony, blending geometry with cosmic philosophy in ways that mirror the Indus approach. The same DNA of order, proportion, and water management would reappear in India's later architectural marvels: the stepwells of Gujarat, the grid city of Jaipur, the mandala-like temples of Khajuraho. The Indus civilization proved that order itself can be sacred, that the truest technology is balance between human need and natural law. They built no pyramids to awe, no ziggurats to intimidate. They built systems that worked, that sustained life, that honored the relationship between body, water, and earth. If civilization is remembrance, then the Indus Valley was remembering how to live without domination, how to organize without oppression, how to endure through cooperation rather than conquest. Modern satellite imaging has revealed hundreds of unexplored sites along the dry bed of the ancient Sarasvati, buried beneath sand and farmland. When fully excavated, these mounds could double or triple our understanding of this silent culture, perhaps even yield the bilingual inscription that finally unlocks their script. Until then, the Indus remains the most silent of the great civilizations, its voice hidden in unbroken seals, its wisdom encoded in geometry and drains. As we journey east to ancient China, we carry the question the Indus poses. Can a civilization achieve greatness without grandiosity, mastery without monuments, immortality through grids rather than gods? The next chapter takes us to a land where the measure of heaven met the pulse of earth, where invention flowed not from conquest but from harmony with natural law. Morning mist rises over the Yangtze Valley, curling through bamboo groves like the breath of dragons. The mountains emerge slowly from the fog, layered silhouettes fading from dark to pale as distance swallows detail. This is a landscape shaped by water and stone, by the slow carving of rivers and the patient accumulation of sediment over millennia. To the ancient Chinese, this was not wilderness but text, a living document to be read and harmonized with. Their philosophy did not separate humanity from nature but saw both as expressions of a single underlying pattern, the Tao, the way that flows through all things. To understand the cosmos was not to conquer it but to align with its rhythms, to move with the current rather than against it. This worldview shaped every aspect of Chinese technology, making it not merely functional but philosophical, not just clever but wise. Near the city of Nanjing, hidden within a mountainside, lies one of history's strangest artifacts. The Yangshan Quarry contains 3 immense stone blocks, partially freed from the bedrock but never moved. The largest, still attached to the living rock, is estimated to weigh 16,000 tons, more than 10 times the weight of the Baalbek trilithon. Its surface is smooth, its edges geometrically defined, yet no ancient text records its purpose or the identity of its creators. Historians have speculated that the stones were intended for a Ming dynasty mausoleum, but the sheer scale exceeds any known method of transport, ancient or modern. Some researchers suggest the stones were never meant to move, that they served as experimental models, a megalithic laboratory where engineers tested the limits of mass, balance, and structural integrity. If so, it reveals a civilization willing to invest enormous resources not in completion but in understanding, in pushing the boundaries of what was possible simply to see what could be learned. This fascination with balance and natural law defined Chinese innovation. During the Han Dynasty, the polymath Zhang Heng invented the world's first seismoscope, a bronze vessel adorned with dragons and toads. When an earthquake occurred hundreds of kilometers away, one dragon would release a bronze ball into the mouth of a waiting toad, indicating the direction of the tremor. Inside, a system of pendulums and levers translated invisible vibrations into mechanical motion, creating a device sensitive enough to detect quakes beyond the range of human perception. Modern engineers have reconstructed Zhang Heng's seismoscope, and it works, proving that over 1,800 years before the invention of modern seismology, Chinese scientists had already learned to listen to the Earth's heartbeat. But China's gaze was not fixed solely on the ground. It stretched upward to the heavens. In 100 CE, astronomers constructed the armillary sphere, a nested system of bronze rings modeling the movement of celestial bodies. It was more than an instrument. It was a philosophical diagram, a three-dimensional map of cosmic order rendered in metal. As its rings turned, manually or later by water-powered mechanisms, the sphere mirrored the rotation of the stars, allowing observers to track the positions of planets, calculate eclipses, and predict celestial events with remarkable accuracy. During the Tang and Song dynasties, these devices evolved into intricate astronomical clocks powered by water wheels and escapement gears, centuries before similar mechanisms appeared in European horology. The Chinese did not view time as linear but as cyclical, an endless turning of seasons, dynasties, and cosmic ages. Their clocks were attempts to synchronize human activity with the great wheel of heaven, to ensure that rituals, plantings, and governance occurred in harmony with celestial rhythms. This same pursuit of harmony guided their greatest inventions, technologies that would reshape the world. In the 2nd century CE, Kai Luan revolutionized communication by inventing paper, pulping tree bark, hemp fibers, and fishing nets into a surface lighter and more adaptable than silk or bamboo. From this innovation flowed the machinery of memory, books, bureaucracies, maps, and art, all the written voices of humanity made possible by thin sheets of dried pulp. Then came gunpowder, born not from military ambition but from Taoist alchemical experiments seeking the elixir of immortality. Monks mixing sulfur, saltpeter, and charcoal discovered instead the fire of transformation, a substance that could propel, destroy, and illuminate. At first it was used for ritual fireworks, celebrations of celestial events designed to ward off evil spirits. Only later did it become weaponized, turning divine spectacle into conquest. Even in destruction, the origins remained sacred. The compass emerged from similar philosophical inquiry. By observing magnetite, a naturally magnetic stone, Chinese scholars realized it could orient itself toward a constant direction. They floated it in water or suspended it on silk, creating the world's first directional instruments. But before it guided sailors across oceans, the compass was a tool of feng shui, used to align tombs, homes, and temples with the unseen forces of wind and water. The magnetic needle pointed not just north but toward harmony, helping architects attune buildings to the flow of qi, the life energy connecting heaven and earth. These discoveries, paper, gunpowder, the compass, along with Zhongheng seismoscope, are often called the four great inventions, though in truth they represent a single continuous impulse, the pursuit of balance between the visible and invisible, the material and the cosmic. Even Chinese metallurgy reflected this philosophy. The technique of cast iron, developed centuries before Europe, allowed artisans to pour molten metal into molds, creating objects of exact proportion. Bronze mirrors polished to perfection still reflect clearly after 2 millennia. Some bear concentric patterns that, when illuminated by sunlight, project intricate designs onto walls, optical technology hidden within art. Chinese knowledge was never separate from virtue. The philosopher Laozi wrote that to master the world, one must act in accordance with its flow. Invention was not domination but cooperation, not forcing nature to submit but learning its language and speaking it fluently. If ancient China possessed geometric precision, astronomical knowledge, and engineering brilliance comparable to Egypt, Sumer, or the Maya, could this too be remembrance, fragments of an older tradition rediscovered and refined? The same harmonic ratios seen in Chinese observatories appear in pyramids, ziggurats, and Andean temples, separated by oceans yet speaking the same mathematical dialect. As we leave the valleys of China and journey west across the Pacific to the high Andes, we carry the question of continuity. Were these cultures learning independently, or were they all students of a forgotten academy, scattered survivors of a world before the flood? The next chapter takes us to Tiwanaku, where stones sing and legends speak of gods who walked after the waters receded. The air at 4,000 meters is thin enough to shimmer, each breath a conscious act. Here on the Altiplano of Bolivia, where the Andes flatten into a cold ocean of light, the sky seems close enough to touch. The sun burns with a clarity unknown at sea level, and the wind carries whispers from stones older than memory. This is Tiwanaku, a city built at the edge of the sky, where water, stone, and starlight merged into a single sacred geometry. Archaeologists date its origins to at least 1500 BCE, but radiocarbon tests and geological studies hint at something older. Structures built when Lake Titicaca's waters were higher, lapping against walls now stranded inland. At its heart lies Puma Punku, the Gate of the Puma, a complex of stones so precisely cut they seem almost machined. Scattered across the plateau are blocks of andesite and red sandstone, each weighing between 100 and 130 tons. Some bear H-shaped cuts, their angles measured in fractions of a millimeter, their surfaces flat to tolerances that rival modern manufacturing. Drill holes, straight grooves, and interlocking notches appear as though shaped by laser rather than chisel. Andesite is one of the hardest stones on Earth, second only to granite in resistance to abrasion. Yet here it is, carved with a precision that defies explanation. Conventional theories suggest stone tools and sand abrasion, but experimental attempts to replicate the work have produced only crude approximations. The time required to shape a single block using primitive methods would stretch into years. Yet Tiwanaku contains thousands of such stones, aligned and fitted with geometric perfection. To the Aymara people who still live on the high plains, the answer is simpler. These stones were sung into place. Their ancestors spoke of Viracocha, the white-robed god who emerged from Lake Titicaca after a great flood, bringing with him light, mathematics, and the arts of civilization. When his work was done, he walked west across the ocean, promising to return. Whether myth or memory, the legend carries an echo of lost technology, knowledge that could alter the nature of stone through sound and understanding. Recent acoustic studies lend subtle weight to this ancient intuition. Engineers examining Calcasieu, Tiwanaku's great temple enclosure, have recorded resonant frequencies that amplify specific tones. When sound is produced at particular pitches, the air between stone pillars oscillates, creating audible standing waves. The arrangement of walls, corners, and chambers seems designed to control vibration, to transform architecture into an instrument that responds to human voice and natural harmonics. The gateway of the sun stands at the center of this mystery, carved from a single 10-ton block of andesite. Its lintel bears an intricate relief of a central deity surrounded by 48 winged figures and rows of smaller icons thought to represent months or cycles of the year. The carving is both art and astronomy, a calendar etched in stone and calibrated to solstices and equinoxes. At dawn on the winter solstice, sunlight passes directly through the gate, striking an altar that once received offerings. This alignment was not accidental. Tiwanaku's builders were synchronizing ritual with celestial precision, creating a physical axis where human ceremony and cosmic motion intersected. Their mastery extended beyond stone. Metallurgy at Tiwanaku reached levels rarely seen in the ancient Americas. Furnaces produced alloys of copper, tin, and arsenic, creating a form of early bronze long before its appearance elsewhere on the continent. These metals were not merely decorative. Small eye-shaped clamps cast from bronze were used to join massive stone blocks, an innovation so effective that the technique would not be rediscovered until modern architecture. Archaeologists have found molds, smelting sites, and slag deposits, evidence of an industrial system powered by charcoal and controlled airflow, perfectly adapted to the high-altitude winds. Agriculture on the Altiplano posed extreme challenges. Frost by night, blazing sun by day, thin soil and scarce rainfall. Yet Tiwanaku's engineers invented the Waru system, a network of raised planting beds surrounded by water channels. During freezing nights, the water absorbed heat and released it slowly, protecting crops from killing frost. In the morning, the channels reflected sunlight, increasing photosynthesis and extending the growing season. This biothermal regulation allowed cultivation of potatoes, quinoa, and maize in one of the harshest environments on Earth. Satellite imagery has revealed thousands of hectares of these raised fields still traceable across the landscape, remnants of what may be the first example of climate-adaptive farming on record. Everything in Tiwanaku was constructed as equilibrium. Light and shadow, water and air, tone and mass. The temples, statues, and canals form geometric ratios that mirror those found in music, the same harmonic proportions used in tuning instruments. Standing within Calcasieu at sunrise, visitors often report a faint hum, a resonance that seems to emanate from the stones themselves. Whether this is wind, acoustic reflection, or something deeper remains contested, but the Aymara elders have no doubt. The stones still sing the frequencies of their creation. The fall of Tiwanaku came around 1000 CE, likely due to prolonged drought and climate shifts that disrupted the agricultural systems sustaining the population. But the precision of its design, the mathematical elegance of its carvings, and the sheer scale of its monuments suggest something more than primitive innovation. If this civilization harnessed the power of sound and geometry, if it understood resonance as a tool for shaping matter, then it may represent a fragment of an older scientific tradition shared with other ancient sites across the planet. The pyramids of Giza, the terraces of Baalbek, the ziggurats of Sumer, each reveals the same fingerprint, architecture designed to resonate, to amplify, to transform space into sound and sound into sacred presence. Tiwanaku poses the question most directly. Were its builders inventing or remembering? Did they discover these principles through trial and error, or were they restoring knowledge carried by survivors of an earlier age? Knowledge encoded in stone because stone alone could survive the next catastrophe. The stones remember even if we do not. As we leave the high Andes and journey across continents to the deserts of India, we carry this question with us. The next chapter takes us to Chand Baori, the stepwell of 1,000 stairs, and to Kailasa, the temple carved from a mountain. In India, geometry became devotion, and architecture became prayer rendered in stone. The heat of Rajasthan shimmers above the ochre sands, distorting the horizon into liquid waves. Beneath that shimmering air, hidden within the earth, geometry breathes. At Chand Baori in the village of Abhanari, more than 3,500 steps descend into shadow, forming one of the deepest and most symmetrical stepwells in the world. Built over 1,000 years ago, it appears from above as an inverted pyramid, each stair a line in an equation of survival. In the desert, water is not merely resource but sacrament, and Chand Baori was designed to honor both. Its architecture captures thermal gradients with precision. The air at the bottom remains 5 to 6 degrees cooler than the scorching surface, a microclimate created by depth, shade, and the evaporative properties of stone. Rainwater descending the steps would cool as it fell, then collect in the reservoir at the base, protected from evaporation by the well's geometry. This was environmental engineering centuries before the term existed, a structure that measured not only water but time itself. Standing at the bottom, surrounded by endless triangles of light and shadow, one feels the presence of something greater, a mind that understood pattern not as decoration but as law. Ancient India's technology was never purely mechanical. It was spiritual engineering, a fusion of mathematics and metaphysics. At its heart lay Vastu Shastra, the science of spatial harmony, which taught that every building must reflect the geometry of the cosmos. Orientation, proportion, and symmetry were not aesthetic choices but cosmic obligations. The position of a door, the direction of a staircase, the ratio of width to height, all were calculated to align with the flow of prana, the life energy that animates existence. This philosophy reached its zenith in the Deccan Plateau, where the Kailasa temple at Ellora redefines the boundary between sculpture and architecture. Unlike the pyramids of Egypt, built block by block, Kailasa was carved from the top down, excavated directly from a mountainside as a single piece of living rock. Over 200,000 tons of basalt were removed, yet no trace of debris large enough to account for that excavation has ever been found. How the workers planned the project remains one of engineering's great mysteries. The entire complex, temples, corridors, columns, sculptures, and shrines, maintains flawless vertical alignment, as though the mountain itself were peeled away with invisible precision. Archaeologists estimate the work took several generations, Yet every detail suggests a singular architectural vision. The carvings reveal three-dimensional symmetry repeated across vertical and horizontal planes. Pillars align through multiple floors with tolerances smaller than many modern buildings achieve. Some engineers compare it to laser cutting, each stroke of the chisel guided not by improvisation but by mathematical certainty. Every element of Kailasa was built with symbolic geometry. The temple represents Mount Meru, the mythic axis of the universe, its summit touching heaven, its base rooted in the underworld. To enter the temple is to move through creation itself, from outer chaos to inner stillness, from the noise of the world to the silence of the divine center. Viewed from above, its proportions mirror a mandala, the sacred diagram of cosmic order used in meditation and ritual. Every curve and corridor echoes the rhythms of Sanskrit chants, as though vibration itself shaped the stone. India's fascination with pattern extended into pure mathematics. Millennia before modern calculus, Indian thinkers grasped the infinite. Aryabhata in the 5th century CE described the rotation of the earth and calculated pi to 4 decimal places. Brahmagupta formalized the rules of arithmetic involving zero, redefining it not as emptiness but as potential, the seed from which all number emerges. This philosophy of shunya, void as possibility, echoed the spiritual principle that creation arises from silence, just as geometry arises from the point. In ancient observatories, that principle became tangible. The Jantar Mantar of Jaipur, built in the 18th century by Maharaja Jai Singh II, may seem younger than the civilizations of Ellora or Baori, but its roots stretch back to the same cosmic geometry. Each instrument consists of massive arcs and towers of stone measuring celestial motion through pure form. The Samrat Yentra, a sundial over 27 meters high, tracks the sun's shadow with a precision of 2 seconds. The Jai Prakash, a bowl-shaped structure, projects the sky onto its interior walls, allowing astronomers to read the heavens like a map laid at their feet. These were not metal instruments but stone observatories, representing the culmination of a tradition that saw time as architecture and the cosmos as sculpture. Even India's legends speak a mathematical language. The ancient Sanskrit epics describe Vimanas, flying chariots driven by sound, mercury, and light. In the Samarangana Sutradhara, an 11th century treatise on architecture and mechanics, detailed descriptions appear of machines that fly by fire and wind, alongside designs for rotating temples and automated doors. Whether metaphor or memory, these texts show a civilization deeply aware of mechanical principles, energy transfer, and vibrational dynamics. To India's builders, geometry was devotion. Every stone, every ratio was a prayer inscribed into matter. Temples were not merely houses of gods but machines of consciousness, structures designed to focus energy and align awareness with universal order. When one chants within the halls of Kailasa or walks the steps of Baori, sound and shape merge into a single experience. Vibration becomes architecture, and architecture becomes a pathway to the divine. The stepwells of Gujarat, the water temples of Hampi, the symmetrical gardens of the Mughal era, all reflect the same cosmic blueprint, where geometry, water, and light converse in eternal dialogue. Each structure serves practical needs while embodying poetic truth, cooling systems that are also meditation spaces, reservoirs that double as pilgrimage sites, observatories that function as temples. Perhaps these monuments were not simply acts of devotion but repositories of encoded knowledge, blueprints left behind by civilizations that understood how energy moves through form. From Baori's cooling symmetry to Kailasa's carved mountain, India's builders left us not ruins but equations written in stone. If civilization is remembrance, then these structures remember a relationship between mathematics and meaning, between physical space and spiritual experience, that our modern age has largely forgotten. As we journey across the vast Pacific to one of the most remote inhabited places on Earth, we carry India's lesson with us. The next chapter takes us to Easter Island, where stone faces gaze inward and legends speak of statues that walked to their platforms by command and rhythm. What did the Rapa Nui remember, and what warning did they leave carved in their isolation? Far out in the Pacific, where the horizon curves like an endless ring of blue and clouds drift like slow ships through memory, lies an island smaller than a city, yet older than most legends. Rapa Nui, known to the world as Easter Island, stands as one of Earth's most isolated inhabited places, a volcanic fragment adrift between continents, a world unto itself. And yet here, separated from the nearest landmass by thousands of kilometers of open ocean, ancient hands created one of humanity's most haunting legacies. The Moai, towering stone figures with elongated faces and deep-set eyes, stand in silent assembly along the island's perimeter. Nearly 900 statues are scattered across this small piece of land, some upright on stone platforms called ahu, others lying half-buried in the slopes of the quarry at Rongorongo, frozen mid-creation as though time itself stopped. The tallest known moai, called Paro, once rose over 10 meters high and weighed more than 80 tons. Many others rest unfinished in volcanic tuff, their heads emerging from the earth like dreams half-remembered. To the Rapa Nui people, these were not idols but ancestors, each moai embodying the spirit of a chief or revered elder, channeling mana, the sacred life force that sustained the community. Their placement along the coast symbolized protection, each statue facing inward toward the living, guarding rather than watching the sea. For centuries, the central mystery of Rapa Nui was not why the moai were carved but how they were moved. The island, only 24 kilometers wide, has no trees large enough for rollers and no animals capable of pulling such weight. Early explorers imagined sledges, ropes, armies of laborers, even supernatural levitation. The deforestation of the island made conventional transport theories problematic. Then came a revelation rooted in oral tradition. In 2013, archaeologists Carl Lippo and Terry Hunt, working alongside Rapa Nui elders, tested an old story that the statues had walked to their platforms. Using 3 teams of people and long ropes attached to a replica moai, they pulled and released in rhythmic alternation left, right, left. To the astonishment of observers, the statue began to walk upright, swaying side to side like a living being. It was not brute force but balance, not engineering in the mechanical sense but choreography, physics transformed into dance. The Rapa Nui ancestors had mastered vibration and center of gravity intuitively. Their technology was rhythm, the movement guided by song and chant, transforming the impossible into a communal ritual where energy flowed through harmony rather than struggle. This idea of rhythm as technology echoes across the ancient world, from Tiwanaku, where stones were said to be sung into place, to Egypt, where chants amplified temple acoustics, to Maya cities where pyramids responded to clapping hands. Even the placement of the moai followed cosmic order. Many ahu platforms align with astronomical and navigational points. Ahu Tongariki, the largest, features 15 statues arranged in a line that faces the sunrise of the southern solstice. As dawn breaks, the first light illuminates each figure in sequence, a choreography of shadow and stone that connects heaven to earth. Other platforms align with lunar standstills or the rising of Canopus, a guiding star used by Polynesian navigators across vast oceanic distances. To the islanders, the sky was a map, and the land its reflection. The moai were not merely monuments but celestial markers, anchoring cycles of time to the pulse of the earth. Then there are the Rongorongo tablets, slender wooden boards covered with looping, elegant glyphs of humans, birds, and abstract symbols. Discovered in the 19th century, they represent the only known independent writing system in the entire Pacific. No one has yet deciphered them. Each line must be read in reverse boustrophedon, turning the tablet upside down at the end of each row, following the text like a serpent winding through time. Some scholars believe the glyphs record genealogies or hymns to the gods. Others think they encode astronomical data, navigation instructions, or ritual timing. If the secret of Rongorongo is ever unlocked, it could rewrite our understanding of literacy and human cognition, proving that writing can emerge even on the most remote island, born from memory alone. But the story of Rapa Nui carries a darker resonance, one not of triumph but of warning. As the population grew and resources dwindled, trees were felled faster than they could regrow. The soil eroded, the ecosystem collapsed, and without timber for canoes or fire, the people turned inward. The society that once moved mountains with song fell into division and hunger. When European ships arrived in the 18th century, they found a devastated landscape. The moai toppled, their faces buried, their mana silenced. Later, slave raids and introduced diseases nearly extinguished the culture entirely. The collapse of Rapa Nui is often cited as a cautionary tale about unsustainable resource use, a parable of what happens when a civilization exhausts its environment. Yet it is also a story of memory and resilience. Despite catastrophe, the descendants of the moai builders survived, and today they are reclaiming their language, their traditions, and their connection to the ancestors who walked stone across the island. The moai still stand at Ahu Tongariki, restored and gazing inward, reminders that even after collapse, renewal is possible. Rapa Nui poses a question to all who study it. If isolation could produce such sophistication, such astronomical knowledge, such engineering ingenuity, then what might a connected world have achieved before it was shattered? The Rongorongo tablets, the walking statues, the celestial alignments, all suggest a people who carried within them the seeds of something older, a memory of navigation and star lore passed down through generations of voyagers who crossed the Pacific guided only by waves, birds, and constellations. Polynesian navigation is itself a form of living technology, knowledge encoded not in texts but in chants, in the feel of swells against a canoe's hull, in the flight patterns of frigate birds returning to unseen land. If such knowledge could survive ocean crossings lasting weeks, could it not also survive centuries, millennia, carrying fragments of wisdom from a world before the flood? The stones remember what hands shaped them, even if history does not. As we prepare to weave together the threads scattered across continents, we carry Rapa Nui's lesson. Isolation preserves, but it also limits. Connection spreads knowledge but makes it vulnerable to catastrophe. The balance between memory and forgetting is delicate, and every civilization walks the edge between continuity and collapse. The next chapter gathers the fragments from Petra to Persepolis, from Sumer to Rome, asking whether these scattered innovations are independent discoveries or pieces of a single inheritance, nodes in a forgotten network that once spanned the globe. Across continents and centuries, the fragments begin to connect, forming a pattern too precise to dismiss as coincidence. Each culture built differently, worshipped different gods, spoke different languages. Yet everywhere the same principles emerge. Massive stones moved without explanation, astronomical alignments calculated without telescopes, hydraulic systems engineered without modern mathematics, acoustic properties embedded in architecture, and always the same myths, stories of teachers who came after the flood to restore what had been lost. In Jordan, the Nabateans transformed one of the driest deserts on earth into a city of flowing water. Petra, the rose city carved into sandstone cliffs, glows red at sunset as if lit from within. The facades were chiseled from the top down, temples and tombs emerging from living rock with the same technique later seen at Ellora. But the true marvel lies beneath the surface, an intricate network of dams, cisterns, and channels that captured every drop of seasonal rain, filtered it through sediment basins, and stored it for years. Even through prolonged drought, Petra's fountains ran. The Nabateans made coolness in heat, life from dust, transforming scarcity into abundance through understanding rather than force. To the west in Lycia, high on the cliffs of Anatolia, an equally astonishing tradition flourished. Tombs were carved into mountainsides, some perched 50 meters above the ground, accessible only by rope and faith. They were houses for the dead shaped like homes for the living, complete with doors, beams, and columns sculpted from single blocks. How were such tombs carved with precision at such heights? Rope scaffolds, pulley systems, or something else entirely? The Lycians understood the psychology of eternity. To carve upward was to ascend toward the divine, to make the mountain itself a stairway to the afterlife. Across the ocean in Mexico's Oaxaca Valley, the Zapotec flattened an entire mountaintop to build Monte Alban, a city that seems to float above the clouds. Without iron tools or draft animals, they moved millions of tons of earth and stone, creating terraces, pyramids, and observatories aligned to solstices and equinoxes. The entire city functioned as an instrument, a mountain tuned to the sun, its plazas and temples calibrated to mark the passage of celestial time. In Persia, the empire of Cyrus and Darius extended this principle into administration and ecology. Their royal road ran more than 2,500 kilometers, uniting provinces across deserts and mountains. Messengers could cross the empire in a week, creating a living network of communication that prefigured modern infrastructure by millennia. In Persian desert cities, architects built badgers, wind towers that captured high-altitude air currents and funneled them into homes, cooling by evaporation. This was climate control by design, air conditioning achieved through geometry and airflow centuries before electricity. At Persepolis, columns rose like forests of stone, carved with processions of nations bringing tribute, their geometry following astronomical ratios and their timekeeping aligned with the Zoroastrian calendar, a model of solar precision. For the Persians, order was not merely political but cosmic. Their empire sought to mirror the harmony of heaven, organizing earthly diversity into celestial unity. In the Assyrian heartland, technology took the form of power and intimidation. Colossal lamassu, winged bulls with human faces, guarded gateways, each carved from single stones weighing 30 tons. These guardians were more than symbols. They were proof of engineering capable of transporting and setting such masses with perfect symmetry, demonstrations of strength meant to awe and subdue. Behind them stretched canals, gardens, and cities irrigated by aqueducts rivaling Rome's, reminders that Mesopotamia, the land between rivers, was also the land between myth and machine. And before the Assyrians came the Sumerians, the first to shape time itself. They divided the day into 24 hours, the circle into 360 degrees, the minute into 60 seconds, numbers humanity still uses today, inheritors of their measure. Their ziggurats reached upward as layered mountains, built from clay and cosmic order, connecting earth to heaven through architectural ascent. Their cuneiform tablets recorded astronomy, law, and memory, including the code of Namu, which codified justice millennia before Rome. Proof that technology can be ethical, a system to organize not just stone but society. Rome in turn refined these foundations into empire. Their concrete, mixed with volcanic ash, remains unmatched in longevity, still stronger today than many modern formulations. Their aqueducts carried clean water for miles using gravity alone. Their roads stretched 400,000 kilometers, and their architecture married function with spectacle. The Pantheon's dome floats like a concrete sky, its oculus open to rain and light. The Colosseum's acoustics still carry a whisper to the farthest seat, designed so that 50,000 people could hear a voice from the arena floor. Meanwhile, the Phoenicians mastered the sea. Their ships, built with double prows, could reverse direction instantly, a design unknown elsewhere. They navigated by stars, Sirius, Canopus, Ursa Major, using celestial observation that predated compasses. From their ports came the alphabet, a system of 22 phonetic signs that gave voice to the world, democratizing literacy and making knowledge portable. As Rome fell, the Byzantines preserved its flame. In Constantinople, engineers forged Greek fire, a weapon that burned even on water. Its chemistry so advanced the formula remains lost. Their Hagia Sophia suspended a dome larger than imagination, floating on light that poured through hidden windows, dissolving stone into air through optical illusion and structural daring. In the mountains of Pontus, the monastery of Sumala clung to sheer cliffs 1,200 meters above the valley floor, an impossible feat of design that defied gravity and logic. Across all these empires, a single pattern persists: technology as reverence, whether in water, air, fire, or stone. Each culture sought not domination but balance, a way to live within the laws of earth while reaching toward the divine. It is as if every civilization remembered one fragment of an older whole. Petra preserved the knowledge of water, Sumer the measure of time, Rome the mastery of form, India the language of number, China the order of heaven, Egypt the geometry of stars, the Maya the voice of stone. Each was a node in a network stretching across millennia, a web of memory vibrating beneath history's surface. But if these fragments belong to the same lost inheritance, then where did it begin? What pulse once moved through these empires? A rhythm older than history, buried yet unbroken. Perhaps if we listen closely, the earth still hums with that frequency, waiting for us to remember. The stones remember, even if we have forgotten. The story of human civilization as we have told it runs in a straight line, from caves to pyramids, from bronze to silicon. But when we look closely, the line bends, loops, folds into itself like an ancient spiral. It is not progress but remembrance, not invention but recovery. Beneath every ruin hums the same question: what came before? Across continents the echoes align, megaliths built with impossible precision, myths of gods who walked the earth after floods reset time, the same numbers and ratios repeating across ages and oceans as though humanity keeps awakening to the same forgotten pattern. If civilization is cyclical, then technology is remembrance, and every bridge, tower, and monument is an echo of the first geometry taught beneath an older sun. The pulse has never stopped. It beats through pyramids, through roads, through compass and code. It beats in you. If this journey through ancient mysteries brought you wonder or helped you rest, Please like this video and subscribe to Whispered Empires for more stories that uncover the hidden patterns of history. And tell me in the comments, what fragment of ancient knowledge do you think we need most to remember today? The story is not over. It is only folded, waiting to be opened again.